Hello, I'm Ross Kenyon, and today I'll be talking about the business model for computational simulation. So I work at Regeneron Pharmaceuticals, and I lead a modeling and simulation team that's located in the manufacturing side of the business, which we call as IOPS, or Industrial Operations and Product Supply. My team has three main areas of focus. The first is on drug delivery devices, and what we're doing here is working in partnership with the product design teams as they develop novel devices for our injectable drugs. A lot of the work here is really split up into system modeling, so mathematically modeling the operation of the devices, and then the detailed models of the mechanical performance. So these span the simple linear static analysis to nonlinear materials behavior like hyperelastics and creep to high-speed dynamics like drop testing. Second area of focus for the team is the drug product processing side. So here we do a lot of mixing analysis. Mixing is used all over the drug product processing roadmap. We have models for thermal transients to study freeze-thaw behavior as drug product is taken in and out of refrigeration. And we're also starting to look at clean room design. So we're able to simulate the airflow in a clean room to ensure aseptic conditions. We found this is an incredibly valuable thing to do before a facility is built so we can address any potential issues in advance. The third area of focus for my team is in manufacturing. And here our efforts are focused on developing mechanistic models of the upstream or bioreactor process. We're using metabolic network models of the CHO cell and combining those with data-driven approaches to make better predictions for the upstream manufacturing process. So what I want to talk to you today about is really how we've transformed our way of operating by applying human-centered design principles to our way of working. So like my presentation title suggests, what is the business model for how we operate as a modeling and simulation team? The design thinking process has been captured in various different ways, but the model we're looking at is this double diamond plus model. And really the core of this is a series of diverging and converging steps. So diverging, meaning we're brainstorming, we're thinking of ideas, we're open to possibilities. Converging, meaning we're honing in on something that's going to work. The first phase of this process here is discovery, and that's focused entirely on reframing the problem. So taking the initial problem statement as we understand it, or as it's been communicated to us, and digging deeper. Not just taking things at face value, really getting at the underlying assumptions, working with our customers, empathizing with them, studying them, observing them, truly understanding what it is they need solved. And there's a phrase here that's commonly used in design thinking, which is, what are the customer's jobs to be done? And I'll give you a hint. It's not to run a simulation. They want problem solved and pains relieved. So once we've arrived at a reframed problem, the next step is to move into the solution space, which is shown here as the desirability diamond. And in this step, the point is to think about all the different ways that the problem could be solved. Now, a good tool here is decomposition and recombination. So taking all the possible ideas for a solution, decomposing them into individual constituents, and then looking at the various different ways that they can be recombined to formulate a solution. Now, the traditional double diamond process will be finished here with the arrival at a solution, but there's a third element which looks at the business space. And you might ask yourself, what use is it to think about the business space if we're a modeling and simulation group that's working inside of a large company? But I think this is a really valuable thing to consider, and something, frankly, that I don't think many modeling teams do consider. And how I would interpret this for an internal modeling team is how we're establishing business value through the work that we're doing. So this is looked at through two lenses. One is feasibility, meaning operationally, is this technically feasible to employ? And viability, which gets at, do I have the right balance of revenue and costs? So to apply this way of thinking to our situation, costs are easy to translate because there's labor costs, there's hardware costs, there's computing cloud costs, but revenue is a little bit different. I like to think of revenue in terms of what is the benefit that we're bringing to the business? If we can define it in absolute terms, we will. Time and resources saved, improved process robustness, reduced cost of quality, or we can look at it on a relative or subjective basis. But the way we apply the business-based diamond to our work is this. We've been given a broad charter to operate within the company to employ modeling and simulation to new areas. So we're always faced with choices about where we should apply our resources. By using this double diamond plus framework, we can take a candidate problem, think about it in more detail, drill down to what core underlying problem there is, and then look at what is the business viability of going down this route. And if we think about this in advance, and if we look at a portfolio of projects or a portfolio of options, we can really use this to methodically determine where is the best place to apply our resources and where are we going to get the best results from our effort. So doing this has really helped tremendously to bring a structured process to a kind of ambiguous problem. Now, this double diamond human-centered design process, it can be quite lengthy. If you have a problem that you know has to be solved, it's a great path to take, but there are shortcuts. And I really like this little Venn diagram here, which cuts to the core of what we're trying to do. What it's showing is this innovation sweet spot, which is the confluence of desirability, meaning what is desirable to the customer, what solves their problem. Feasibility, meaning is it a technically or operationally feasible thing to employ? And viability, meaning is it viable from a business perspective? Do the gains and do the returns outweigh the inputs? So if we're faced with a spectrum of possibilities where we could apply our resources, this simplified framework is a great way to filter ideas. And interestingly, it actually maps directly back to the double diamond plus framework. Desirability, of course, fits directly within the solution space, and then feasibility and viability addressing the business space. So when we think about the desirability or solution space diamond, I found that a nice tool to employ is this customer value map. Now, what's interesting about this map is we typically start on the right with the customer jobs. And I mentioned this before in terms of what is the job to be done for the customer. And like I said, it's rarely the case that what the customer really wants is a simulation. What they really want is a device that functions, or specifically a device that functions over a large population or over a long life cycle, or a device that costs less or is more materials efficient. We can also frame this with respect to process design, a process that's robust, a process that can be qualified or substantiated, or the ability to close deviation investigations or avoid them to begin with. So if we look at those various jobs, we can see, okay, what are the pains that the customers are feeling and where are the potential gains? And now we look at the left part of this graphic, we can come in with the products and services that we offer, capabilities that we currently have, or if it's a solution that we've arrived at through this converging and diverging process. And we can break that down into what are the elements of our products and services that create gains that align with the customer's needs, and what elements of our products and services relieve pains, and again, aligning with the customer's needs. Now, it's important to realize that this is an iterative process. This is not a case of just sitting down and filling in all the bubbles of this graphic. So I have to stress the importance of coming in with a proposed solution, applying this framework, testing it out, getting feedback from the customer, going back to the drawing board, reworking it. It's really only through this iterative process and looking at it from multiple angles and getting input from different people that we can really optimize the solution to fit the needs of our customers. So when it comes to feasibility and viability, I've actually found a lot of value in thinking about my team as if we were a lean startup, operating in a real business environment. And if we look at the lean and agile framework, it's very interesting because it's essentially the opposite of the way we're trained to operate in the pharmaceutical industry. The standard procedure for device design is first to do the verification step in terms of, did I build my device right? And then move on to the validation step, which is, did I build the right device? But when you look at it this way, the lean and agile framework is really to do those things in the opposite order. So first, am I building the right thing to solve my problem? And then think about it in terms of, did I build that thing right? So in thinking about this and applying this to the way we work, we've implemented a series of prototyping and storyboards. And I'll be honest, when I first came across this, it had never occurred to me to storyboard out how we're going to solve a problem with simulation. But once we started doing this, we found an immense value to this process. Some problems are really straightforward. Like in the course of the device design process, people come to us and say, okay, this part is cracking during assembly. How do I make it more robust? But when we come across more ambiguous problems, when people come to us with issues in the manufacturing process in terms of decision points relative to time out of refrigeration, or qualification issues with the mixing process, or challenges with respect to product quality, those problems are not so straightforward to solve. So what we started doing is actually coming up with a proposed solution and then storyboarding out what are the simulations we're going to do, what results do we expect to get, how are we going to combine that with experimental results, and how does that fit within the business process or the regulatory process? And then going back to the customer and saying, okay, here's the rough framework that we could use to solve this problem. Does it make sense? What issues do you see? What feedback do you have? And then we can use this to refine our solution. And it's really reduced a lot the amount of time and resources that we need to solve the problem. But more importantly, it's led us to generating solutions that have a greater value to the business. Now, another thing that comes from the Lean Startup Toolbox is the business model canvas. So I've actually been told that a lot of technology incubators have this as a hard requirement for every startup that gives a presentation. And what's interesting about this is that after having gone through the design thinking process, all of those elements that we've already talked about have a neat place on this canvas. So looking at the canvas, there's three elements. On the top left is the backstage components. On the top left is the front stage or customer-facing components. And on the bottom is the profit formula. So in the backstage area, this is where we think about what are the key activities? What are the things that we do as a modeling and simulation organization? What are our key resources and who do we partner with to make these things happen? Now in the front stage area, first you look at who are the customers? What are our relationships with those customers? And what are the channels with which we engage our customers? Then the culmination of that is what is our value proposition that we bring? And this value proposition comes directly from that desirability framework that I showed a couple slides before. This is what gets at what are the customer pains that we're reducing and what gains are we creating with our work? Then it comes to the profit formula, which looks at our cost structure and revenue streams. And I talked about this earlier when I introduced the double diamond framework. So cost structure is a very easy thing to articulate in a modeling and simulation organization. You've got your people, you've got software, you've got computer hardware, you've got cloud resources, but revenue, like I said, can be trickier to identify. So there are some things that can be quantified, like time and resources saved, but there are others that are more subjective and relative. I guess it's important to remember, though, that the subjective and relative things do still matter to the business. They generate value, so we need to consider them in that context as revenue streams. I actually put my organization through an interesting exercise at the end of last year where I challenged each of my 3 team leaders to generate a business model for their function. So it was a little difficult at first to get these technical people to think about this from a business perspective. But in the end, it was a really valuable exercise because it helped us focus our thinking in terms of matching up our capabilities with what generates value for the business. And it formed the basis for a more comprehensive effort to define the vision and roadmaps for the team. So the broader context of all of this is our effort to work towards a future of simulation-driven processes. Over the last few years, we've made a lot of progress as a team to demonstrate clear advantages for the use of simulation in numerous areas of the business. What we're really hoping to do, though, is accelerate that by bringing in the types of business tools that I showed today and use those to refine our value proposition to the business. So in closing, I'd like to thank you for joining me today, and I'll take any questions that you have.
It's a fact, our cars are getting smarter. But with more people and more technology filling our roadways, how do we not only adapt quickly, but also safely? I'll give you one guess. I'm Miss Emma Walsh, and this is Driven by Simulation.
Right now, every company we work with expects to see simulation data.
With virtual prototyping, you can totally save cost and time because you're using virtual prototype to replicate a real scenario.
So it allows you to be able to model accurately where light's going, how it interacts with different surfaces and different materials, and where it'll end.
It's always better to have more simulations.
We can just change the values and get back the results within seconds. So this helps us a lot, especially in the development phase.
A digital twin is so important for us.
So it's future.
How do you build a champion? In this era of Formula One, it takes a balance of skill and science, adrenaline and engineering, a passion for disruption from the design lab to the pit lane, and the drive to not only be faster, but more innovative than the competition. Today we find ourselves an hour's drive north of London at the home of one motorsport team whose mission is to win and to do it differently. Join me as we kick off this journey with a peek behind the curtain at one of F1's hottest and most competitive teams, to explore how engineering simulation is helping to unlock a competitive edge and push the boundaries of what's possible both on and off track. I'm Miss Emma Walsh, and this is Driven by Simulation. No one's driving it.
There is no driver here.
And more than 90% of the accidents are caused by human error. This can be prevented if we really let the car drive itself. And this is where simulation comes in critically.
You could say this is where it all began, with one of the most legendary brands in all of motorsport.
When they fire up the engine, I felt something difficult to describe. You know, sometimes a dream come true, but the story like my one can happen just with the Ferrari family.
The reliability of the CFD simulation for the Ferrari Challenge is the result of the finely optimized technology.
The Ferrari Challenge, the most renowned single-mark championship series designed for those whose passion for racing runs as deep as iconic red hues. I'm here in Maranello, Italy, at Enzo Ferrari's famous factory, to see firsthand how simulation continues to drive innovation at this house of performance and elegance.
If you consider that in the past, the total time that you spend to be ready was almost 2.5 years. Now, thanks to the simulation, in 1 year, we are ready.
From the track to Main Street to the motorway, we've seen how simulation is preparing us for the road ahead and helping us reach the future of mobility faster than we could have ever imagined. But what about the places where there are no roads? Well, prepare to get a little mud on your boots, because today we're miles from the comforts of the design lab to see how simulation is taking us off the beaten path.